I will share my screen now. Okay. I hope my screen is visible to all of you. Hello? Hello?
Yes, ma'am. It's
Okay.
clear.
Thank you.
Clear.
Thank you. A very good morning to all the students, teachers, our father, our principal, Father Varghese Edatichara. It's a great opportunity for me to have a talk with you all today. So I hope all of you are having a great day. So today I'm going to talk on the topic chemical equipment design in chemical industry. So once again, my name is Anisha Mohan Kumar, and I'm a Master of Science student in Chemical and Bioprocess Engineering at the Technical University of Hamburg. I did my Bachelor of Engineering in Chemical Engineering in Bangalore itself, and I'm basically from Kerala, from Palakkad, and my family is settled in Bangalore. So I did whole of my schooling in Bangalore. And then in 2019, I planned to do my master's, and I have come to Germany, and this is my second year. Yeah, I'm hoping to finish my master's this year. So let's start with the presentation. So I chose this topic because this is my one of the favorite subjects in chemical engineering, and it is one of the most loved subjects of all the chemical engineers. I hope I hope to have a very interactive session with you all so that it doesn't go boring, and in the same time, uh, I wish it gets useful to some students who are going to choose their career paths very soon. So let's go into it. So what is chemical engineering? So by definition, it is an engineering field that utilizes several raw materials, any kind of raw materials, and they go through a chemical process and get converted to a product. So this chemical process is the one where mostly chemical engineers focus upon. So it can be process design, it can be process simulation, it can be process optimization. There are so many different fields of chemical engineering, but I am talking only about one small topic of chemical engineering. It is a very vast field of engineering. Not not everyone is aware of chemical engineering. I believed when I joined chemical engineering because to tell my experience, there were only 3 girls in my whole course when I took my bachelor's, but um, that is because not everyone knows about this course. It is not totally chemistry, and it's not totally just mechanical aspects of it. You need to have both all three physics, chemistry, and maths knowledge, along with engineering principles to get into chemical engineering. So let's look at what are the different fields of chemical engineering. So one could either go into biotechnology or pharmaceutical industry, where where you design facilities that use enzymes or microorganisms to create new drugs or medicines. Or one could go into environmental engineering part, where they try to reduce the emissions that are emitted into the atmosphere, or they could or just take the example of catalytic converters in cars. So they try to reduce the emissions of the harmful substances that are emitted into the atmosphere. So they basically perform a redox reaction there. They convert the harmful gases into a less soluble form and then emit to the atmosphere, so that it is harmful still, but it's less harmful compared to the compared to the greenhouse gases. So otherwise, one could also go into industrial chemicals such as detergents, soaps, or even cosmetics. So, so now maybe one can realize how much work goes into one bottle of a detergent. So you could also work in food production, like wine, beer, or any other alcoholic beverages manufacturing, or you could even go to the most loved chocolate manufacturing industry. So you should understand how interesting it could get. And yeah, most importantly, you could get into petroleum refinery industry. This is one of the most important sector of chemical engineering, or the main sector of chemical engineering, I would say. So it's an oil refinery that turns crude oil from the earth's surface into gasoline, diesel, heating fuel, etc. So petroleum, when people specialize in petroleum engineering, petroleum engineers specialize in designing the equipment. So these are the equipment to extract crude oil from the earth. So chemical engineers may focus more on designing of the equipment that implements the chemical reactions which turn the crude oil into something which would be found at the refinery shown here, like the diesel, kerosene, petrol, like that. So, and if not petroleum, you could also work in alternative energy. For example, solar cells, which involve chemical processes to be designed, uh, like the microchips, the solar cells, or mm, like which convert chemical energy from a fuel form into electrical energy, and these can be seen in cars, submarines, boats, planes, and you will learn how these work and how they are made in alternative energy sector. So now, what does a chemical engineer actually does in these fields? So let's get into it. So it's mainly called scale up. So this is a term you'll hear a lot when you research about chemical engineering. So this is the main difference between a chemist and a chemical engineer. So chemist, so they so take for an example, um, in a chemistry lab where you can determine the formula for making a new detergent. So they have, so now that's a small scale. It's very limited to a test tube. It's very limited to only that lab. So you have the formula, and that's where the job of the chemist ends. And when you have to produce when you have to produce the same detergent in bottles, in several kiloliters of bottles, you need to have a reactor. You need to have not one reactor, you need to have several reactors. A reactor, I meant just a vessel which needs to be designed in a proper specification. So it needs to be designed so that so large that a man can fit inside, just like this. A man can fit inside the reactor. So huge the reactors are. So what do you think? What do you think they're doing? What do you think they're doing? Any idea? Anybody? Any guesses? Hello. Hope nobody is sleeping. Hello. Okay, it's okay. So it's not just adding more chemicals here. So take the example of beer manufacturing. There are so many people, even in Kerala, we all know that there are people who manufacture beer or wine at home. So everyone knows the formula for doing it. They add yeast, enzymes, and they do the manufacturing in a very small scale, just limited for a family. So take it some company who manufactures beer. So they just can't do it just like they do it at home, right? So they take huge reactors like these, which are shown in the picture. They're like really huge. They look like they uh, they almost fill the whole size of a room. Such big reactors they are. So and they have to be sized properly, and you need to design the cooling jacket. You need to design the cooling jacket of the uh, for the reactor. It's basically a water layer surrounding the reactor, so that your product doesn't go too hot. So and also you have to keep in mind. So when you do it in a lab, it's very obvious that you need to add certain amount of yeast, certain amount of enzymes, and whatever other ingredients it is. But when it comes to a reactor scale or a industrial scale manufacturing, you need to have proper piping and connections for the feed, for any extra additives that are to be added to manufacture any product. Now we are taking beer, so for taking beer, say what amount of yeast is to be added. So each of the editors will have each pipeline. So everything should be designed in a controlled manner. Everything should be followed with a standard procedure. It should be followed with Indian standard operating procedures. All these standard procedures are to be followed while designing these pipelines. And so these reactors also require design safety components like temperature sensors, which lets you know when the temperature goes too high or too low. Flow sensors, how much component is supplied into the reactor, that is controlled by flow sensors. Control systems also, they they uh, they control the flow of the system, and the pressure release valves, they check the pressure inside the vessel. So only when these components are satisfied, a plant is running successfully. If there's a little failure by a chemical engineer, there's a huge loss for the whole nation, I would say. It's a big mistake. So every step a chemical engineer takes is very vital. But in the other sense, it is a very interesting field to work upon. It's so nice to see something working when you have designed it yourself. So it's a very wonderful field. So in summary, what a chemical engineer does. So they concern themselves with the processes that that turn raw materials into valuable products. So the necessary skills that encompass all design are testing, scale up, unit operations. So unit operations, I mean every process that is employed in a chemical process is called a unit operation. Say filtration, sieving, drying, everything is a unit operation. So yeah, distillation, mixing, all that is a unit operation. So all these processes in together are the necessary skills that are needed for a chemical engineer. So what are the actual, when I go in depth to the unit operations, what are the different kinds of, so unit operations itself, they are divided into several categories. So say for fluid flow processes, it's filtration, solid fluidization. For the heat transfer processes where only the heat is transferred and not the mass, so it's called evaporation or heat exchange. Where the mass transfer processes occur, where only mass is transferred or how much mass is consumed. For that kind of processes, gas absorption, distillation, extraction, adsorption, and drying are employed. And also thermodynamic processes are also under unit operations called gas liquefaction, refrigeration, and also some mechanical processes like screening, sieving. I hope you understand sieving. Sieving is just like the filtration of the solid particles, so that you get more finer particles for your processes. So all these are the initial steps for the raw materials before you charge them or before you put them to any reactor or vessel. Some of these steps are employed, and some of these steps are also employed in between the reactions. So say like a separator is operating, and you need to have an evaporation unit after that. So yeah, that is when all these unit operations are used. So what is basically uh, process equipment design? So it all depends on size and overall design. So if the equipment is too large, it will have a large footprint, but whereas when you have a smaller equipment, there's always limitations for it. It leads to earlier failure. So therefore, properly designed equipment is essential for production of high quality and effective products. And in the same time, uh, the cost also is kept in mind while designing any kind of product. So it should go hand in hand that cost has to reduce, but still you have to get a good quality product. So that's where the design aspect plays. So I told that chemical engineering is where raw material is getting converted to product. So in between process is the one a chemical engineer does. So a process is a route through which a raw material is converted to product, and the equipment or a reactor or any kind of vessel is the place where we convert that raw material to product. So, design, it's not something very big. It's just to get the dimensions of the equipment, the construction of the construction of the equipment, what material you use in it, and what all accessories you need for that particular equipment. It's not just one or two equipment you design for one plant or say one process. So if I take, for example, so this is a ammonia synthesis process. It's not just one absorber or one regenerator that is used for a single process. So everything depends on the size of the process or the size of or the amount of product that is to be generated. So if the CEO of the company says that you have to produce 10,000 kiloliters of 10,000 kilotons of ammonia. So you need to design how many absorbers you need and how many regenerators you need. So for so many regenerators, you need so many reboilers and so many condensers. So that's how it is. So you design for one and you scale it up to many. So a process design takes up both chemical and physical operations. So the major considerations that are to be taken are the material of construction, as I said, the arrangement of equipment needed to ensure proper functioning, the pipeline sizes, and the principal instrumentation. So the process design, so we plan everything. So we plan that so many equipments are required. So all the equipments are designed with this material, and these valves are to be present. Everything is decided, and at the end, for us to show it to somebody else who doesn't know designing, or the person who manufactures all these equipments, we need to show them in some simplified form, just not what we did, but in some simplified form. So that's called a process flow diagram. A process flow diagram will look something like this, but this is a very, very small one, very basic one, I would say. You get a huge process flow diagram, which is given to the manufacturer uh, for him to assemble it, for him to manufacture it. And it's not only for the manufacturer, it's for everyone who works with that process, who's involved in that process. It's very important that one designer makes a process flow chart like this, and this is to be approved by government officials to be installed in the plant, and then only it's installed in any plant. So, what are the basic steps of process design? So, first of all, we need to know the concept and definition of the process. What kind of a process we are going into? What is the product is to be that is to be produced? We develop a flow sheet that, as I told now, we need to have a complete flow chart of what we are exactly going to do, how we are going to produce it, and what is the end product, what is the raw material going in, how much material is needed for the how much material is needed for the product and all that. So number of the types of equipment that is to be included in the process, the number of equipments that is to be included in the process. And the next step is designing the equipment, how the control valves are to be placed, where the inlet, where the outlet is going, and is there any other connection for steam, water, and all that is to be designed in the equipment. And economic analysis part is a very important aspect in designing. So operating costs are the costs which incur throughout the process, throughout the production of any product. And capital costs are meant to be the initial costs which are required while installation of the plants. And optimization is something where you reduce you things you can reduce must be reduced, and you have to get a maximized efficiency or a purest product you can get. So that is called optimization. So let's say if you you try to reduce the cost of the raw material, you convince the suppliers, or you reduce the cost of construction of material for any reactor. So that is the way you can reduce the cost in a chemical plant, and then by that you can increase the efficiency of any product. That's called optimization. And after all this is done, a detailed report is prepared. And then submitted to government officials or the company heads, and it should be approved by them. And then only the whole process is started. And till here, everything is just planning. Everything is just on papers and nothing is to be implemented. And only once the report is approved by any higher authority of yours, and then only any work starts. So there are several design constraints that are to be kept in mind, as I told you now. So there are external constraints and there are internal constraints. External constraints are represented by the solid lines in the outer periphery, and the internal constraints are represented in dotted lines in the inner periphery. So, so I can say that only internal constraints are in a hand of a chemical engineer, not the external constraints. Only, say, for choice of process, it's in a designer's hand what process he should choose. There'll be several ways to produce ammonia or produce phenol or any chemicals like that. So it depends on you what process you choose, which is more effective, which gives more efficiency. Yeah, so that is your choice of process, and process condition is at what temperature you operate it at, what pressure you operate it at. So even that is your choice. And materials, so what raw materials you want in it, what what materials you can reduce, and what materials of construction you can use for your equipment, and that is materials. And personal is the number of people working for that process, or the investment that is to be given to that whole process, and the time, how much time you take to finish the whole process, in what time frame can you finish the process. So all these details are to be given to any of official who has to approve it. So only these internal constraints are in a hand of a chemical, sorry, in the hand of a designer. So, but when you come to the external constraints, say to be safety regulations. So safety regulations are to be followed as it is given from the government. So you cannot change any of it. You have to follow all of them, and you have to make a design that falls under these safety regulations. And the resources, if they are limited, and you want some other resources, you have to take whatever is available, or you have to resource them from somewhere outside. But you have to keep in mind about the cost, about the availability, and all those things. And the physical laws, where the plant can be implemented, where it can be actually started. It shouldn't be near to any residential areas or anywhere where people are living. It should be out of any human interference. So there are many laws that have to be followed, and standards and codes. Standards are codes of basically for the pipelines, for the vessels. So every vessel and every pipeline have to be designed under certain standard and codes. So nothing cannot be nothing can be deviated. Everything has to be followed in say I can give you an example for designing a pressure vessel. You have to follow ISO 8259/1969. So that is a standard code you have to follow for designing a pressure vessel. So, and the government controls is like you shouldn't dispose of the waste into any seawater, into the environment. You have to dispose of them properly, efficiently, or you have to reuse them. So those are the government controls, and economic constraints are not in your hand at all. So it is somebody else who's funding the project, or it is so many people, or it must be the government who's funding the project. So whatever funds you get, you should make sure that your whole process is working in that particular economic condition. So those are the design constraints. So the chemical equipment design is mostly applied when you have to modify or add anything to your existing plant, when you have to increase the capacity of any existing plant, or when you have to take up a completely new process from a laboratory research to a pilot plant. So pilot plant study is in between lab and industrial scale production. It's not very small, but it's not very big. It's a in between study where you don't have to invest a lot of money, but you can understand all the uh, all the aspects of industrial scale production as well. So that is it. So how can you really approach designing of any equipment or any pipeline? So it's starting from business, what you have to, you have been assigned what you have to do, what kind of a process you're supposed to do. So you decide on that, and then chemistry, how the reaction is, how is the chemistry part working behind it. You have to have a clear understanding of it. and the reaction, what are the reaction condition, what temperature, what pressure, what kind of synthesis, what synthesis route are you going to opt, all that is coming under reaction. Separation is when you already have a product, you have a product already, and you have to separate them into different subproducts based on maybe boiling points, melting points, density differences. All these parameters are there for separation of any product. So that comes under separation. So, and utility system is basically for heat exchange networks. So it can be a heat exchanger for or any other utilities such as steam, water, refrigeration, air, such kind of. And safety is the most important aspect of any chemical design, and there are two kinds of analysis called Hassan and HAZOP analysis. Hassan is hazard analysis and HAZOP is hazard and operability studies. So these two rules are to be continuously followed when you are designing any plant. So only when these are approved, you can operate any plant. So the conditions to be fulfilled when you install a plant are optimum process conditions, appropriate construction material of construction for the equipment, and you should make sure that your designed equipments have proper strength and rigidity, and you test them in a pilot plant, as I said, and you make sure that they have satisfactory performance and they're going in a set of range you've set in and they don't deviate much, and you make sure that the deviation is limited to a very low level, and reliable methods of fabrication you should have, and there shouldn't be much maintenance work that should incur in future. You should make sure that everything you install at first are the best. Of course, there will be maintenance and repairs in futures, but it shouldn't be the next immediate year of installation you get maintenance and repairs. It should go on for a long term, and you should keep that in mind, and that's how you should proceed with design. And the safety requirements, as I said, are the most important. You should check for safety valves, all ventilations to the plant, and exhaust to the plant. Everything must be checked. So only if these conditions are fulfilled, you can say that your design is acceptable. So every basic design, as I said, it can be represented through a onion diagram. It looks like an onion, so it's called onion diagram. So we can take some examples now. So this is a basic flow chart, very basic flow chart, which only has a reactor and a separator. So let's take a reaction, say A plus B, giving C plus D. Okay, so this A plus B reaction is happening in the reactor. So this reactor is the it can be included in the core of the onion diagram, and it's the first layer of the onion diagram. This is called the reaction. So this is where the reactor applies. So now A and B is reacting and it gives product C and D. So now we have the product C and D. And as I said, you'll have the need to separate these products. What if your manager wants to get the product C separate and D separate? So you let them in a separator. So this separator, it comes under the second inner core of the onion diagram. It's called the separation. So for the separation to happen, when the separation is happening, you need either heating or cooling. For that, you need reboiler or you need condenser for the process to happen. So all these heating and cooling happens. So these fall under heat exchange network. So in between, when the reaction is happening and when the product is getting produced, even then heating and cooling is happening. So these are heat exchange networks. Even these fall under heat exchange networks. So for these heat exchange and heating and cooling to happen, you need utilities like steam, water, or air, or refrigeration, anything like that. So those utilities fall in the last core of the onion diagram. It's called the utilities. So this is the basis when you basis of chemical equipment design. When you start studying chemical equipment design, this is the first thing you will be thought about, and uh, this is the very basic uh, understanding of any chemical plant. So let's see. So let's see what all equipments are basically designed by using an onion diagram as a reference. So we can design shell and tube heat exchanger. So as I said, shell and tube heat exchanger is kind of a heat exchanger. There are several different kinds of heat exchangers available, but this is a very basic one and it's the most important one in the chemical industry. So, and it falls under heat exchange networks. And condenser and reboiler is also heat exchanging unit, but just they either do just heating or just cooling. They don't do both, so they even they fall under heat exchange networks. And crystallizer and evaporator, they do both heat exchanging jobs and they even separate products, so they fall under both heat exchange and separation course. And distillation column is again a separator unit. It separates products based on different boiling points. So if one has a higher boiling point, it gets separated from the top, and if the other product has a lower boiling point, it gets separated from the bottom. So the efficiency depends on the construction of the distillation column. So pack column is again one such kind of a column which is used to separate products, and that even falls under separation. And reactor types, there are several reactor types. Reactor on the vessel I was talking about, there are batch reactors, there are continuous reactors, there are plug flow reactors. There are several kind of reactors, and all these reactors fall under the innermost core of the chemical industry, that is reaction. So what do we exactly calculate when we are doing design? So for every equipment, every small equipment we are designing, we need to calculate certain parameters for our equipment, say to be a heat transfer coefficient, pressure drop for heat exchange networks, condenser, boiler. All these are just the main parameter. There are several more parameters to be estimated in every calculation, and these are the parameters for evaporator, and these are the parameters for pack column, and these are the parameters for distillation column. So this is just a basic of it. I just wanted to give you a rough idea what all you really need to estimate in a design. So these are these are the these are some of the parameters that you need to estimate, and all these estimations are done using standard formulas, procedures, and you have to follow all those standards when you're calculating each of the parameters here. So this is just show you an example. This is a small version of a design I made myself for one of the project in our course. So this is cumene to phenol production, and this is just a part of the production. It's actually a very big, very huge process flow diagram. I've just shown you a part of it. So these are the 3 distillation columns. They're used to separate the products, and they're going to storage tank. So this is basically the last part of the process. I've not come from the starting. So this is how basically a process flow diagram looks, and all these are the process control valves. This is reboiler, this is condenser, and you can represent the different routes it is taking, what process condition it's using, what process synthesis route it's using. And yeah, so this is basically how a process flow diagram looks. This is the end stage of your designing, I would say. Yeah, this is it. Really, it's a very interesting field to study. It's really nice. As I said, it's really nice to see something working when you have designed it yourself. So, just to conclude, I would say chemical engineering is not at all just chemistry, but you need to have chemistry knowledge, but you need to apply so much of mechanical aspects of engineering, and yeah, there's so much to study. This is just a very basic subject of chemical engineering. There's a lot of field to explore, and then there you can even study process simulation. As I told, it's basically you have to study programming languages and build a model, and then see how efficient the model is with the programs, and then you compare with your basic design, and you see how efficient your synthesis is with the model and your design. So that's how every processes these days are going on. So yeah, this was all that I had to talk about. I hope all of you liked it, and now I'm open to questions. Thank you.
Thank you, ma'am. It was really informative and took us to the new world of chemical engineering. Thank you, ma'am. For the kind attention of the participants, kindly make a check in the chat box. A link is being forwarded. Please fill in and submit it. Now, this interactive session, friends, you can text your queries in the chat box.
Good morning, madam.
Good morning.
I am
You can call me Anisha. I'm just a student like you. So I'm just here to help you with whatever questions you have, anything. If you want to know anything, if you have to go abroad or your further studies, I think I can help you in whatever knowledge I have.
Okay, miss.
And you can call me Anisha.
Okay. Can you please tell us a safe way to dispose waste from chemical green plant?
So mostly disposing of waste is a very important aspect of any chemical plant. So in most of the situations, none of the chemicals are like just completely disposed of to the environment. They're mostly recycled and used in the same plant for further processes, and they made sure that they're not sent out immediately. So if at all, after many usage, if they have to be deliberately sent out of the plant, they are sent to recycling units, or they're just not disposed of to the seas, or just to the soil. They're treated in a very very ethical manner in a sewage disposing plant and sewage treatment plant. Or most of the time, I would say all the chemicals are regenerated and used in the chemical plant itself, and there is not much waste that is generated. And that is the most important aspect of a design engineer, that you make sure that there's no much waste generated. There are waste generated, but there no much waste generated, and all the products or all the byproducts that are generated are regenerated into your plant and used again for several other processes. It's not that you're generating only one product at a time. There might be several different products you are generating, so it can be used for any other process as well. Yeah, so by proper treatment or by varying the process conditions, you can change the texture or the chemical aspects of the liquid and then use it again in the plant. Yeah, I think that should be the answer.
Thank you. Thank you. Thank you.
Good morning, ma'am.
Good morning.
I am Prashasti Gupta of class 9. My question is that how is the economy of a country depending on chemical plants?
Okay, so chemicals are, I think chemicals are not just used as chemicals in the outside world. They are basically the raw materials for every other industry, like textile manufacturing, plastics, resins, construction domain, or yeah, anything like that. So every industry out there are using chemicals. So I think it is the most important sector of the economy, and they make up to like 60% of the economic growth, I would say.
Okay, miss. Thank you.
You're welcome.
Good morning, ma'am. I'm Ajulia from class 12. Ma'am, my question is, will the construction of a chemical plant affect the ecosystem? And also, is it safe to live near a chemical plant?
No, it's not at all safe to live near a chemical plant, and that is the most important aspect. When you try to when you even think of installing a plant, it should be in a place that it is far away from all of the residential areas, and it is safe to be operated up to several kilometers. There are no human interference. There'll be only people who are trained to work in those chemical plants, except then there'll be no families or any livelihood going on near the plants. That's made sure.
Thank you, ma'am.